Hi student, welcome to Mr. D class. Today I'm going to teach you how to complete the square of the trinomial. Before to explain how to do this, I need to give you the characteristics of the quadratic, in this case quadratic expression, what is the characteristics of the perfect square trinomials. Characteristic number one. The characteristic number one is you need to see the term here, the first term, the coefficient of the first term is a perfect number. The coefficient of the second term is a perfect number. Then, what is the perfect number? One number is a perfect number when this number has exactly square root. Now, the first characteristics, the coefficients of the term with x squared is perfect number. And the constant term is a perfect number. What is another characteristics? In another characteristic is in the middle term here. When you find the square root of the coefficient here, and you find the square root of the constant term, and you multiply both square roots, and you multiply that product by 2, the final answer is the coefficients of the term with the variable x to the first power. To explain this more better, I want to do one example. In my example, I have 4x squared plus 12x plus 9. I have some question in this example. Is the following trinomial a perfect square? Remember the characteristics. The first term, the term with x squared, in this case, the term with x squared, this number had to be perfect number. Now, if you find now, you get the number 4, a squared is 4, and you find the square root, and the answer is 2. Then 4 is a perfect number. With the same sim, I had to select the number 9. Number 9 is the constant term. The b squared is 9. The square root of 9 is 3. Now, 9 is a perfect number. The first characteristic is satisfies. The first coefficients, the coefficient of the term with x to the second power is perfect number, and the constant term is a perfect number. This is the first characteristic. Second characteristic is now analyzed in the coefficient of the term with the x to the first power. In our case, I have 2ab is 2 times the square root here, times the square root, you find the square root here is 2, the square root is 2, and you put it here, you multiply here, and another square root here is 3, and now you put it here, and now finally you multiply 2 corresponding to this 2, times 2 is the square root of 4, times 3 is the square root of 9, and when you do the product, finally our answer is 12. 12 is our answer. Now, I'm going now to check is the coefficient of the term with the x to the first power here in this case is 12. You see, this value is 12. Now, because this value is 12, you hear this is 12 here, and corresponding for the product of 2a and b, we can conclude finally that 4x squared 12x plus 9 is a perfect square. Another example. Is the following trinomial a perfect square? we do the same. Now we select now the coefficient of the term with the x to the second power. I select now the constant term, and I find now the corresponding square root. The square root of 9 is 3. The square root of 25 is 5. Then 9 and 25, they are perfect number because they are exactly square root. Now, second characteristics. I need to multiply 2, multiply 2, multiply 2. This is happening. 2 times A times B is 2 times 3 times 5. 2 times 3 is 6 times 5 is 30. Now, as you see, in this case, 30 is not equal to 18. Remember, the term here is 2AB have to be equal 18, but in this case 30. Then I conclude now that my expression is not the perfect square. Listen now, it's very important. The coefficients, these coefficients, 9 is perfect number. 25 is perfect number. But the middle term, the coefficient of the 10 with x to the first power is different, a product of 2 and the square root 3, square root 9 and the square root 25. Because they are different, 30 is here is the product, is different of 18, then my expression is no perfect square. Now I want to introduce how to expand a binomial to square. How to expand a binomial to square. You know, you can apply, because it's a square, you multiply the first binomial, you multiply 2 times. Now you have ax plus b, and you multiply ax plus b times ax plus b 2 times. Now, what are you going to do? You multiply ax times x is ax, because a times a is a squared, and x times x is x squared. Continue with the FOIL. X times b, ax times b is axb. Now what are you doing? You multiply ax, you multiply by b, and the answer is axb, or aba. Continue with the FOIL. B times ax is the same thing, abx. And finally, b times b, and you have b squared. Now, as you see, I have these two expressions, and they are like terms because the exponent of both terms are 1. Then, what you have to do, you add like term, and it's 2abx plus b squared. Finally, when you have a binomial, this is, when you have a binomial, ax plus b, any binomial, whatever, to square, what you have to do? You select the first term, and the first term is to square. Number 2, the last term, you get the second term here. This is here is the constant term to square. Now, remember, you select this one to square. The last term is second term of the binomial to square. And the term on the middle, this term is a product of this times 2. You say ax times b, x times b times 2. And now you expand the expression. We're going to do another using example. I need to expand this expression. Now it is very easy. You see, I have here 2x, the first term of the binomial, and I have here 6 is the second term of the binomial. Now, using this expression, the first term is the first here, this one, 2 square. Because you had positive here, you write positive here. What is the second term? The second term now, you multiply the two terms of the binomial, 2x times 6, and what you multiply is 12x, 2x times 6 times 2. Remember, times 2. This 2 is here. Okay? And the 2x times c is the product of 2x times 6. Plus this term to square. Remember, using the expression is b, this is b squared. Now this is 6 here, 2 square. And the finally is 2 squared is 4, 2 times 2 is 4 times 6 is 24, and 6 squared is 36. And you expand the expression because this expression here is a perfect square. Next example. In this example is the process inverse. I give you the expression in expanded form, and I need to write this expression in this form. Okay, this is in expanded form, and I need to find A and I need to find B to write this expression in this form. Number one, I need to find what is A and I need to find what is B. What do you have to do to find A and to find B? Well, number one, remember A is the square root of this number. Okay? Now, A is 3 because it's the square root of the coefficient of the x to the second power. And B is the square root of the constant term, is 16. Now I have A and I have B. But to do this, I need to check first is my expression is complete square. You can use only this is this expression is complete square. Then to move from this expression to do the to write the expanded expression in this form, you need to prove that the expanded expression is a perfect square. Now, it's clear I have the first characteristic, 9 is a perfect number and 16 is a perfect number. What I have to do, I need to multiply 3 and 4 times 2 to check if this answer is 24. What I'm going to do is 2, A is 3, B is 4. When you multiply 2 times 3, 6 times 4 is 24. Wow! 24 is equal to this coefficient. Then my trinomial is a perfect square. Now I can write now, this is 3a, this is ax, remember ax, this is ax minus, because you have negative here, 24x plus 4 squared because this is b squared, and now this is a perfect square. Because this is a perfect square, I can write my expression in expanded form in this form. Okay, now finally, ax is 3x and b is 4. Negative because my expression here is negative. I need to remember something that's very important. The sign on the end here, always, to be perfect square, always had to be positive. If you have some trinomial, when the sign, this one, had to be positive always to arrive to the conclusion that it's a perfect square. If this sign is negative, never is a perfect square. Okay, continue. This is final answer. Continue with another example. In this example, it's a little more difficult. This is a very important now because this method will give you the beautiful method to solve the quadratic equation in the future. This is very important. For example, I have this expression, x squared minus 18x plus 4, and I need to write this expression in this form. If you see here on the middle here, I have a perfect square. I have a perfect square. Now, the first step is analyze is my expression is a perfect square. What I have to do, the coefficient of the x squared is 1. Then the square root of 1 is 1. The constant term is 4. The constant term is 4. And the square root 4 is 2. Here is 2. Okay? When I'm going to multiply 2 times 1 times 2, it is 4. It's different of 18. Then my expression, this expression is not perfect square. What I have to do now, I'm gonna use x squared. I'm gonna use 18x. I use these two terms. I'm gonna use, listen, I'm gonna use these two terms, no 4. I'm gonna use these two terms to create this completed square. Okay, to do this, I need to find what is the value of b. What is the value? Because a is 1. A is 1. I need to add some number to this expression such that when I add some number, the new expression is completed square. But if I know now that 18 is equal to times a times some value of the b, I'm going to use this value of the b to complete a square. Now when you divide by 2, the value of the b is 9. But remember, to add my expression some number to complete a square, I need this number to square. Now b squared is 81. What am I going to do now? I'm going to add, listen now, I'm going to add 81 to my expression, to this. I'm going to add 81 to this expression. And I'm going to subtract 81. Because if you add 81, you need to subtract 81. Because if you not subtract, you change the expression. Yes, I add and I subtract. But now, listen now, this expression now, this one, let me show you. This expression now, this one, this expression is a perfect square. This expression, this x squared minus 18x plus 81 is a perfect square. Now, I write this as this using this expression. A is 1, is 1x, minus the square root of 81 is 9, and I subtract 81, negative 81 plus 4 is going to be negative 77. And now I write now I write now my expression using this. Now, this is the final answer. Okay? I write my original expression using this. That's the final answer. Another example. Another example. Remember, in this case, the coefficient here is 1. And this is a constant term is 9. I need to check if this expression is a perfect square. Now, this is A is 1, B is 3, the square root of 1 is 1, the square root of 9 is 3. Now I just say 2 times 3, 2 times 1 times 3, 6 is different of 10. You see? 6 is different of 10. They are different. Then this expression, this is no perfect square. No perfect square. To write my expression as like this, in this form, I need to complete a square. Listen, I need to use these two terms. I'm going to use these two to complete a square. Forget a 9. I use a 9 to the end. But I have to select the first two terms to complete a square. Then I need the value of b. When I find the value of b, and I use b squared, and I add here, I did the complete square. Now, what I have to do? Now, you say 2, remember it is 2ab, because the expression here is 2ab. 2ab is 10. I need to find b. Remember, I need to find b because when I find b and a b, I use b to square and I add to my expression. I did the complete square. Now, when you divide by 2, the value is 5, and 5 squared is 25. Then what I'm going to do? I'm going to add 25, and I'm going to subtract 25 to my original expression. Now, this expression, this one is a perfect square. Now, this coefficient is 1. You select 1x minus, this has to be positive. It's a little mistake. Sorry, here has to be positive. Positive here, because the value here is positive. Here number is positive here. Plus 5, because b is 5, and negative 25 plus 9 is negative 16. Now, I write my example in this form. Okay? Another example. In this case, it's different. Because you see now in this case, 3 is no perfect number. 7 is not perfect number. Then finally, this expression is not perfect square. But the question is, write this expression, write this one in this form. What I have to do? You see, I need to group these two terms. I'm going to group these two terms. And I'm going to find the common factor. Now, 3 is a common factor. You see, 3, the common factor between 12 and 3 is 3. When you get a 3 upside, you say 3 divided by 3 is 1, and 12 divided by 3 is 4. Now, because 3 and 12 are, 3 is a common factor between 3 and 12. Now I'm gonna work now here inside. Because I want to complete a square now inside of this parenthesis. You see here, I have 2ab. Now 4 is equal to ab. But a is 1. Now, if you divide 4 by 2, you have the value of 2. The value of b is 4. And 2 squared is 4. What are you going to do? To complete a square of this expression, to complete a square of this, I'm going to add 4 inside of the parentheses because 4 is the value of b to square. But as you see, I add 4 inside of the parentheses. And the parenthesis is multiplied by 3. Really, I do not add 4. I add 12 because 3 times 4 is 12. If I add 12 to my expression, I need to subtract 12. Because if you add 12 and you do not subtract 12, you change the expression. And now finally, listen, finally, this is a perfect square. This is a perfect square. Okay? This is a perfect square. Now, finally, the value of A, the value of the A is 1. The value of B, finding here, this is B, is 2. And 7 minus 12 is negative 5. And you solve the exercise. Okay? This is some exercise I'm recommending to use now in your practice class. That's the moment I will give you 3 minutes to copy this exercise. And have a wonderful day today. If you have some question, text me in my YouTube channel, and I am here to help you and everything. Thank you for paying attention to my video. Have a wonderful day. I give you this example. Copy this example to work in your practice class. Thank you again, students. Have a wonderful day. See you in the next video. Bye.